In this question, we're asked to determine whether or not these molecules have hydrogen bonding between the molecules or hydrogen bonding between the molecule and water. And for each case, we're going to need to draw the Lewis structure. In other videos on this channel, you can see details about how to draw Lewis structures. Here, I'm going to focus on the hydrogen bonding interactions, and I'm basically just going to show you the Lewis structures. I'm going to move this up a little bit so I have a little bit more space. So first, in order to have hydrogen bonding within a molecule, we need to have an N bonded to an H, an O bonded to an H, or hydrogen directly bonded to fluorine. If you have one of these situations, you can have direct hydrogen bonding. In order to have a hydrogen bonding force with water, you only need an N, an O, or an F. These molecules can hydrogen bond with water. So let me give you an example of a molecule with an OH. And I'm going to pick something simple like CH3, OH, which is methanol. So methanol can hydrogen bond with itself. And I'm going to show the interaction with water just because it's a smaller molecule, but you can see this is very much like water, except it has a methyl group, a CH3 group on this side, and a hydrogen on this side. The oxygen of methanol will hydrogen bond with the hydrogen of water, like so. And it can actually hydrogen bond with the second hydrogen of water. And this is a very strong intermolecular force. Notice, it's not as strong as the intramolecular force, this covalent bond between oxygen and hydrogen, but this oxygen to this hydrogen is roughly 3 times longer than this oxygen to this hydrogen, so it's a very strong intermolecular force between water and, in this case, methanol. The hydrogen can also hydrogen bond with water, like so, except the hydrogen, I should have drawn this as a dashed line, will interact with the oxygen of water. So this is a hydrogen bond here. So this molecule can both hydrogen bond with itself and can hydrogen bond with water. You can imagine if this was just a CH3 and this was a CH3, you now have a hydrogen bonding with itself. Again, back to the general rules. The general rules, if a molecule has an N directly bonded to an H, an O directly bonded to an H, or an H directly bonded to a fluorine, in this case HF, is a common example. Okay, in fact, in general chemistry, probably the only example, and in other courses as well. Basically, we are going to look for NHs, OHs, and possibly HF, and then you can have these bonded within the molecule. For it to hydrogen bond with water, it only needs an N, an O, or an F. So that's basically the difference. So let's look at the first example. And to draw the Lewis structure, I'm going to draw it here. Note that this one's a little bit weird because oxygen is in the center. If you try to minimize formal charges and you put chlorine in the center, you'll find out that there are formal charges, and in this case, all the formal charges are 0. So this is the best Lewis structure. This has an O directly bonded to an H, so it can hydrogen bond with itself. It can also, of course, hydrogen bond with water. Molecules that can hydrogen bond with themselves can also hydrogen bond with water. So that's basically how that works. If we look at CH2F2, we have C, F, in this case, it's a little bit of a tricky example, but it can't hydrogen bond with itself because even though this molecule contains F and H, they are not directly attached to each other. So you need the H and the F, again, hydrofluoric acid is the only example, directly bonded to each other. Here you have an F and an H, but they're not directly bonded, so it's no. But this can technically hydrogen bond with water because this fluorine can interact through a hydrogen bond with the hydrogen of water. That being said, my guess is this molecule is not soluble in water, so this interaction is relatively weak, although it is possible. So we are going to put yes here. In the last case, ethane, we already have the Lewis structure, so I don't need to redraw it. There are no N's, O's, or F's. If you do not have if you don't have a nitrogen, an oxygen, or a fluorine, the molecule can not only not hydrogen bond with itself, it cannot hydrogen bond with water as well.